Hey everybody. We're going to start talking about properties of minerals now. Sorry, I exited out of that. And I am going to open up your science notebook as well. Kind of put that with the properties of minerals tab. So in your notebook, you may want to open up to slide, I think it's 4. It's either 4 or 5. I can't remember. So let's click. No, not 4. It's going to be 7 actually, so slide 7 we're going to head to. Yes, this does look confusing, but again, the stuff in the middle is a lot of like fill in the blank vocab stuff, so you can pause the video at any time and kind of fill this in, and you see like the titles of the sections that they're chunked together. What you can also do here, properties of minerals, we'll go over this in a second, and then we'll talk about Mohs hardness scale, okay? But anyways, let's look at properties of minerals. Now, some of you, when we talk about minerals, you may think that they are rocks, and they're different. Minerals are going to be inorganic compounds. Like when we talked about compounds, they're not living, okay? That's pretty much what it means. They're not living. They're naturally formed on Earth, so like they're not man-made, like no one made them in a factory. They're found everywhere on Earth, and they are solid, okay? Rocks, they are going to be more so classified by how they're formed. This leads us into the rock cycle. We're not going to talk about rocks right now. That's later on next semester when we move into the layers of the earth and we talk about the rock cycle and how these rocks are formed. Rocks are actually made up of different types of minerals, okay? So minerals are like a simplified version, if you will. Minerals will have like a definite crystal structure that gives some of them that really crystal look, whereas rocks really don't have that. If you've ever been to the Perot Museum, I know it's hard to go right now, but if you've ever been to the Perot Museum, you would know that like there's that one section, I think it's the lower levels, that has a lot of minerals there, so kind of interesting. Just like I said, minerals are inorganic. They're not living. They're solids, and they're naturally formed on Earth. They're made up of elements from the periodic table, okay? That's why this is chunked into this section of chemistry. And they have a crystal structure. They're made up of atoms, molecules, compounds that give them that like really crystal look that some people probably even refer to them as crystals, you know? But moving in here, let's see. So how we identify minerals, some important vocabulary, and it's in this section here on this page that we're looking at. We know that we can identify a mineral by its color. Now, there are like over 4,000, 5,000 minerals out there on Earth, so we don't just identify minerals based on one property. We need to identify minerals based on a lot of different properties, okay? So color's one way, not the only way, because think about it. If there's like over 4,000 or 5,000 different minerals, do you think there's only one mineral that's going to be blue? No, there's going to be many. So we also can do a streak test. So scientists, and they'll use this like tile plate, if you will, and they'll take the rock and streak it on there, like take it and literally scratch it on the tile, and whatever color it leaves behind can tell us a little bit more about what mineral it is. For example, gold, and then there's pyrite. If you have a piece of gold, like in this picture, it looks very similar to pyrite. And gold it's going to streak and leave gold. But when you streak pyrite, it leaves like a brown color, similarly to why some of like fake jewelry out there, if you leave it on when you shower and stuff, or too long when you sweat, your finger or like your neck area, it could like turn kind of like that brownie color because it's pyrite. It's fool's gold. It's not real gold. Another way to identify minerals is its luster, if it, like how light is reflected from it. So it's either like super shiny, not shiny, metallic, not metallic. Could have like an earthy look to it, chalky, pearly. Those are all words that you can use to describe a mineral's luster, okay? Then we have hardness. Now we have a Mohs hardness scale, and on your notes we'll talk about it when we get there, but Mohs hardness scale is a way to identify the actual hardness of a mineral, and that can tell us a lot, especially if two minerals look alike. Density. Density has to do with the sinking and floating when it comes to gravity, and we're going to talk about density, I promise. But I mean, some minerals have a specific number associated to it, and that's its density. And if the number associated to it is greater than 1, that mineral will likely sink. And if it's less than 1, that mineral will likely float. The reason why is because the density of water is 1. So anything greater than 1 will sink, anything less than 1 will float. The breakage pattern, there's 2 words. They're kind of weird, but they are in science. They're cleavage and fracture. Fracture, you think of like fracturing a bone, just like brittle, like cracks everywhere in weird pieces. And then cleavage is more so like you think of laying bricks to a building, and it's like smooth, okay? Like it kind of cracks or like breaks very smooth, and where you could like rub your hand on it and it's just very clean, okay? We just went over all this with color, so you could pause here and on your notes, if you needed to, you could fill in whatever you need. You know from prior videos I said that if you need more room, you can also add a slide and, you know, right on there. But hopefully you don't need too much more room. I don't want you to spend all day on this or anything. So yeah, and then we talked about streak. As you can see, the streaks on the plate. You can use different color plates. Like they obviously used a different color for this one to make sure that it was streaking, because it left a white streak. And look what color this mineral is. And then see this color of the mineral? It leaves like that black, maybe like granite kind of color. The luster, again, you could have some that look metallic-y or pearly. These are all words that you could use to represent color or to represent luster. Glassy, pearly, greasy, silky. Those are all words that could be used to represent a mineral's luster, okay? Mohs hardness scale. This is a big one, so this is where we're going to talk about it. In your notes, if you want to, you can fill in the fact side, or maybe like just kind of put in here like a fact you found out instead of just copying from the slideshow. But if you want, you can like fill in the slideshow with these crazy mineral names so you can kind of get an idea. But this was named after, his technical term is a mineralologist scientist, Moh. His last name is Moh, and he developed a scale that compares minerals and their resistance to being scratched by each other or by another object, okay? So I'll tell you, the mineral diamond is the hardest mineral out there, okay? Mohs hardness scale goes from 1 to 10. Diamond is going to be your hardest mineral. This means that diamond cannot be scratched by other minerals out there, okay? It's that tough. Hence the reason why they put diamond in a lot of jewelry. Sorry, the bell's going off. Hence the reason why they put diamond in a lot of women's jewelry, because diamond can withstand being accidentally hit on like a table or something, and they'll put it in especially engagement rings, because a lot of women accidentally hit their engagement ring like on the table or chair or something, and it's not going to scratch because diamond is that strong. So diamond can actually scratch the example minerals under it. Okay, so these are just examples. There are more out there, of course, but I mean, these are examples for the hardness scale that we're talking about. So diamond can scratch all these ones below it, but nothing's going to scratch diamond because it's the strongest. Okay, the one on the lowest level is talc. From what I've learned about talc is so soft. If you were to hold it in your hand and like take your fingernail and scratch it, it's going to come off like chalk. Okay, I want to say talc is used in baseball as well, but talc, you could literally like scratch it with your fingernail and it's going to flake off similarly to sidewalk chalk because it's so soft. So all these minerals above it at all the other levels are going to like demolish talc. Like they can scratch it, break it, you know, all that stuff. And I even showed you the example here. Like if you scratch it with a fingernail's stronger than talc. It's going to scratch it. So with that being said, anything that is below, like if I look at this mineral, and this one's apatite. If you look at apatite, it's a 5. It's going to scratch everything below it. So anything at 4, 3, 2, and 1, it's going to scratch. Anything above it at 6, 7, 8, 9, 10, anything above apatite is going to scratch apatite because it's not stronger. Like apatite is not stronger than these ones, if that makes sense. There are other objects over here on the side just to kind of show you like apatite is about the same strength, a little bit less strong than like a pocket knife. Okay, so pocket knife will scratch apatite because it's stronger than it. It's a little tricky to understand the scale, but remember it's a scale from 1 to 10. 1's your weakest minerals, 10's your strongest. Density. We're going to learn about density. Remember, that's the topic we talk about that has some math in it, where we're going to do addition, subtraction, multiplication, and division. But you will be able to use a calculator, and we will go over it. But density is the amount of matter per unit of volume. So we're basically taking mass and volume and putting it together. Okay? We're literally trying to find out if certain objects float or sink in water. Okay? And like I said, each mineral will have a certain number associated to it. As you can see, these ones in here. And it will tell us more about the gravity, which corresponds to if that mineral can sink or float. When I mentioned cleavage earlier, you can kind of see that these minerals, like when they're broke, they break in like a clean, smooth break. Okay, it just looks like if you rubbed it with your finger, it would be kind of smooth. So like the lines are just kind of smooth, and you know. Fracture, however, you can kind of see, sorry, that's still a bell because they're testing out the bells and I'm doing this at school, making this video for you. But for fracture, I mean, there's going to be different kinds, but in general, it's going to look way messier than cleavage. Okay, cleavage is going to be like a very clean break. You can kind of see like certain parts of it are very smooth. But like when I think of fracture, it's just kind of like everywhere, kind of rough and irregular for the most part, okay? Even though this one's smooth, it's not like the edges here are just kind of like chunked off and kind of messy, so it's still considered fracture. Some common uses for minerals you can kind of see here. I mean, you're not expected to memorize this by any means, but you can see we use minerals in our daily life, and I think a lot of you would be shocked to know, like if you were to go and look up certain minerals, what we actually use them for. Like calcite, we actually use that in toothpaste. Crazy, right? But yeah, I mean, that's pretty much it. Some of you know words like gemstones for birthdays, like your birthday month color. I would be a December Okay, so the turquoise. And some minerals are cut to become gemstones. Okay, so like they're cut a certain way. Mineralogists or like the diamond people will cut them to make them into gemstones, to make them beautiful. So that's really it in this section. If you need anything, let me know. But remember in your notes, you might need to like rewind and go watch the video in this section. Remember like the slides that I kind of went through quickly. You could go back and pause and kind of fill in what density means, what cleavage means, what fracture means. But yeah, that's about it. Remember, anything you fill in your notebook is fair game for quizzes and tests. Okay? Alrighty.